Again. All right, so I've got the slides here. All right, so let's talk about this stuff. All right, so the components. By the way, let me see if I can get this irritating Zoom thing out of the way. There, that might get it out of the way in fullness of time. View, slideshow. All right, so we talked about this. The indexer is collecting all the data and putting it in a database. The search head is able to search it, and you have forwarders. What is this garbage? I guess the slideshow automatically progresses or something stupid. Full screen was probably what I want. All right, so, all right. And the forwarder is sitting on all your devices to forward data to the indexer. That's what you put on every web server and firewall and everything else in your network. And so if you buy any kind of proprietary gadget like a router, you have to get or write a forwarder for it. But anything of any importance in the industry, somebody has already written a Splunk forwarder for it, and you can find it and download it. If Splunk didn't write it, somebody in the Splunk community wrote it, or whoever built that gadget wrote it, because nobody would want to buy your gadget if there wasn't a way to forward it in Splunk. That's one of the many advantages of having a industry standard product. Everybody wants to play ball with you. So the indexer takes all this data and compiles it into an index and creates compressed files so you can fit a lot of data on the server, and the search engine searches this stuff efficiently. And you have various search heads, and if you have a big enterprise class deployment, you end up having to have a lot of big powerful servers serving each of these roles. Of course, for us, it's all just going to be on one computer because we're only doing practice deployments. But if you get the more advanced Splunk certifications, you learn how to configure these complicated arrays of servers to do it at enterprise class. So the search heads let you do the queries, and they also let you make these reports and dashboards and visualizations so you can have pie charts and beautiful PDF reports and all the stuff that your management probably wants, summarizing the results of what you find. So that we talked about this, the forwarders are these little things that forward the data from all these. So the web server's running and it's keeping a log of all the people that have disconnected sessions in case they're attacking you, and all that data is being forwarded by the forwarder over to the indexer, which chews on it and stores it in the standard format in the Splunk database. There are other things out there like a deployment server to push out Splunk software to your many nodes, and a cluster master to handle your clusters of machines that are all working together to run Splunk, and then some kind of license master to handle all the licensing of all those multiple Splunk indexes. Sort of like these days, if you install Microsoft Windows, you have to have a Windows license server to deploy the licenses, and all that is stuff we're not going to need in this course, but you should be aware it exists. That's what you have to do at the enterprise class level. And that's why I said an introductory level security analyst would never deploy any of this. This is a big job for an advanced person. What the beginning people do is use it after somebody else has got it running. Yeah.
So this is both for bare metal and cloud-based?
Yes, I think it's all the same, both bare metal and cloud. And I think Splunk even has a cloud version where you put it in their cloud, like everybody else these days. So you can do that too. And but of course, that's probably more expensive. So the single server is not very useful in the real world, but it's what we do for practice, where you just put everything on a server, all the data is generated by the server and everything, and you can do that. And this is what you do for setting up and testing, but of course you can't handle enough data on with just a single server doing everything to keep up with the speed of real traffic at an enterprise network. All right, that's basic deployment. Then you have forwarders forwarding the data into your single server, and it's doing everything. You can have a multi-instance where you have many indexers and many forwarders going up to the search head. And this is what you do as you grow to be bigger. You have several servers splitting these things apart, and you might have a different type of data sent to each indexer and a group of indexes. And that's why you'll see at the start of every Splunk clear, you typically specify the index, because you might want to search just one index. And as you get more bigger, you might organize your data and have web traffic here and traffic from America here and traffic from Asia there and various other things. So you can make things faster by limiting to only search the area of interest. So you can add these search head clusters. So you have a whole cluster of machines working together to make the searches faster, because as you'll see, searches get kind of slow. You're all going to be sharing a couple of cloud machines in those projects, and you'll see it is pretty easy, especially if you write sloppy searches, to make it really search hard. The thing I've learned in practice, which by the way, I don't really understand, is that the speed of the search is determined by how many things it finds. I would have thought it was determined by how many things it has to hunt through, but it's not. If you write a query with 100,000 results, it will take like 5 minutes to run. If you write a query with 10 results, it'll run like that. So the thing to do is to narrow it down, and I'll show you how to do that. All right. And so you've got index clusters that replicate data, and you've got non-replicating index clusters. So all these indexers could each have a complete copy of the data just for load balancing, or you could have separated it by categories where the different indexes have different amounts of data. And of course, those serve different purposes. All right, and then there's installing Splunk, which is ridiculously easy. There's a Windows installer and a Linux installer, and all you do is run the installer like anything else. You install this thing called Splunk Enterprise. You'll install a 30-day trial of Splunk Enterprise, which is the full version with all the features. And then after 30 days, it will ask you for a license key, and if you don't have it, it will demote itself to Splunk Free, where you don't get the fancy features like the only user you have now is administrator and stuff like that. But for everything we care about, it still works the same. So when you install it, you have to have some open ports on your machine. Of course, it's going to end up listening on several ports. And then you download this thing and you just run the installation, which is very easy. There's step-by-step instructions in the labs from the Splunk course, but it's ridiculously obvious, especially if you put it on Windows. It's just like everything else, just double click, next, 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 next. If you do it on Linux, it's not much more than that. All right. So here's you can control Splunk. Yeah. Yes, you totally can. That's where I put it. Virtual machine's fine, cloud machine, yeah, any of those are fine. And typically you control Splunk from the web interface by just clicking on things in a browser, but you can do it from the command line too. And there's this Splunk executable, and you have various commands. You can change the Splunk port, change the port it's listening on. If you're already using that port for something else, you can start and stop it, and you can define user accounts and everything else. And that means you can script things. That's the reason this is there, of course. You could write a script that deploys all your settings, but for us, we're pretty much always going to do it in the GUI by just clicking on the menu there, which has the same effect. And the last trick is getting data in. You got to collect the data somewhere, and we'll do a bit of that in the hands-on. So what happens is you have a forwarder, typically forwarding data from some device, or if you're in the case where we're deploying it on a single machine, we'll actually want the logs off that machine. So we're just going to read the contents of a folder. So the data comes in, then the indexer has to parse it. The data is in a different format for every product, so it has to hunt through there. There are certain things it must define, like the date and time. That's really important to Splunk. It really wants a date and time for every event, so it has to find that. And it would also like to find all the other meaningful things like source IP and port number and URL and whatever it might have. So it will try to figure that out, and it will offer you a template of known things like Apache files and such. And if all that fails, you can write your own parser. You can say, take from the 15th character to the 30th character and call that, name, and take the next 10 characters and call that user or something. You can do it by hand, which is kind of painful. And you don't usually have to, because usually you're just installing standard products and there is a known template for that standard product. But if you have written your own software that makes its own goofy log file, then you will have to write your own parser. And the indexing is where it parses it and then sticks it in the index. And then it has the license meter, which I mentioned. You can only index so many megabytes per day of live data, and you pay for more megabytes per day of data. So at the end of a month, if you've exceeded your allocation, your Splunk server will warn you, and then it will shut down unless you pay Splunk for a bigger license. That's how you pay. You pay by the amount of data. And for the free version can only do, I think, 500 megs a day, or it's 500 megs a month or something. Whatever it is, it's not much. You very soon hit it. All right. So you can see files and directories. You can read direct network data. It will not store the whole network packets like Wireshark, but it will read network data, look for HTTP requests and other things, and store entries sort of like Cisco's NetFlow. You can read Windows logs, of course. You can read Unix logs, of course, and so on. It has many, many other ways to add more entries, but those are the common ones. So you look for metadata in there. Typically you have source, which is the input file or something, then the host name of the inputting device, and then source type is basically the format the data came in, what type of data it was. And then index, refers to which one of your indexing heads you're going to or something. And that's, in our class, we're just using main for everything. In the bots v1, we're going to use bots v1 as the name of the index. That's just whatever label the people that configured this chose to put on the index. In case you are a big enterprise, you'd have multiple indexes. Most people just have one index called main if they're doing the simple test things we're doing in this class. So you can do it in Splunk Web. You just click on data inputs, and then you click on items to choose it. So I add a new data input, and now I can choose various ways to bring it in. I can upload a file. If I have a file of like Apache logs I just want to analyze, you can monitor live stuff. You can connect to a live forwarder, but what we're and you can also connect to a file locally. And so that's what I'm going to do here. For example, you go to files locally, and you just point to a local log file and then put it in. That's one way to do it. Then you just set the source data type. If it's any kind of normal product, there will just be a data type for whatever you're doing. This is web, and here's various types of web server logs you might have. And if it's a known type, it will just automatically parse it and find all the goodies and give them descriptive names and make your life easy, which is almost always what you see. So it determines the source by just looking at the file, and it's usually pretty good. So unless you're doing something exotic, it's pretty automatic and easy. And there's pre-trained source types here for everything you might want, like databases and operating system logs, and pretty much every other common product is all ready to go. So then you determine where it's going to be saved, but just putting it in the default location is usually fine. And that's it. You go to review page and submit, then you'll end up with some data in there to see. It's available for searching, although there might be a delay as the time it takes to index it. If you go a whole big file of stuff, it has to chew through the file and process it, and it's not really available for searching until you do that. So that's it for the course material stuff. And I think this is probably fine. I just want to demonstrate the extra credit stuff, which is the most fun. And so that is here. Okay, I'll just open it, this page here. Okay, so if you go to the class here and you go down to the projects, here's where you go through the modules. And at the end of the modules, I just had you turn in a screenshot. You'll import a file of data they give you with this stuff about Buttercup games, and then you'll search for how many games were sold this month and stuff and get a screenshot. And it's all very much point and click. By the way, they have questions for you to solve. And if you go to the last page, they have step-by-step instructions with the answers. So don't struggle too hard. Just go to the last page and you'll find complete instructions. So you should be able to do it. If not, let me know. But don't struggle and get stuck. Read to the end. The last page has solutions. And feel free and use them. It's a training product. Then when you want to challenge yourself, here's what you do. Boss of the SOC. And that's what I'm going to show you. This is why I taught this class. This is good, clean fun. And this was a CTF that I went and played at Splunk, and we won it. And then we went to the next one, we won that one too. And I said, oh, I love this. I got to teach this. And then I found they open sourced it. And so I downloaded it, and I said, how hard would it be to put this available to the whole world? And it turns out it's not that bad. So what you do is connect to my server. I have two servers, Splunk and Splunk 2. I'll just go to this one. Now, in order to prevent people from DOSing them and everything, it has a login. It has a user account. You have to log in as student 1 with a password of student 1 to get in. It's basic authentication. A box will pop up. You got to put in student 1 to connect. That way you just don't have a bunch of idiots all over the whole world. All right, now once you're in, everybody's just the administrator all the time, which by the way means you could shut off the server, delete the data, and ruin it. If you do, I'll recover it from backup. That doesn't happen too often, so we're all right. But this is why, of course, this is kind of insane. The whole world has admin rights, but nobody seems to be much messing it up. So this is Splunk in all its glory. If you click this, it takes you to the home page, which is what we're seeing here. And there are a couple of add-ons here, but I don't care about them. I just care about the search. This is all we're going to do. I should mention a few other things, though. If you go to settings, you can do administrative things like control your server. So you can go to server settings, and here you can change things like the port number it uses and where it stores the data, and you can reboot the server and so on. So this is where you make general changes like you might change for a WordPress server or something. And you can adjust things here, but you really don't need to adjust any of that for this. The data's already been imported. All you need to do here is search. If you click search, you get to the search page, and here's where you could put a search query. This is where you start. This shows you an overview of the data. All the data here is from 6 years ago up to 3 months ago, because the original data was generated 6 years ago by Splunk administrators. Then they used it as a live CTF for a year. Then they open sourced it. Then I copied the data and put it up here, and I did that 3 months ago. When you first install Splunk, it starts scanning live network data. So I've got some old stuff and some new stuff until I figured out how to turn off the live scanning, which was 3 months ago. So that's what's going on here. And you can go to a data summary to see what kind of data exists. And this is very good data. This is like there are 8 hosts, and the hosts have IP address or names or something. And the host I don't find very useful to play with. What's fun to play with is sources. Sources are nice and meaningful. So here's what you've got. You've got Suricata data. Suricata is an open source intrusion detection system. It knows about viruses and web attacks and DOS attacks, and its events are things like Trojan detected, DOS attack detected. That's good stuff. So that's what's coming from here. This is some kind of a web server log, INET pub. This is a Windows-based web server in C INET pub. You can see that. Here's some event ID data. That's Windows event logs. Here's Microsoft, Sysmon, and Application Security and System. Those are Windows event logs that have been forwarded in. Here's information from the Windows registry, and so on. There's several devices here all sending logs up. And you can also see in the source type, various types here. FGT is FortiGate. There's a FortiGate firewall in the network, and it's sending logs of what it detected and what it bounced and such. All those things are here, and that's the point of it. You get to search real data. So let's start. All the data we care about is in this index, bots v1. That's how you get the real Splunk data from the extra additional data that I caught by accident just during my setup. So get rid of that and put in that index here. Now, if you search right now, you're going to find nothing. What's the problem? That's right, the last 24 hours. All the good data is 6 years old. So I have to fix that. Now, if I just change this to all time right now, it's going to find all 1 million events and take 10 minutes and irritate me. So since I want to start by just showing you everything, I'm going to switch and turn on sampling. This is what this is here for. If you have a huge data set and you don't even know what to do, then you don't really want to see every event. So I'm going to switch to 1 in 1,000. Only show me every 1,000th event, just so I get an overview. That'll make it faster. Now I can search for all time, which I think is here. Yeah, all time. Now I can search, and there they are. And it went nice and fast. Now it only found 1,000 events instead of 1 million events. And by the way, it's a random sampling of 1,000. So if you do it again, you'll get different exact events. Now I can see what these events look like. So here's an event from an Ubuntu server. Here's more Ubuntu events. It was like a bunch of things came. Here's something more, just about like Ubuntu on top. And so whatever the last events were Ubuntu, here's some kind of XML Microsoft thing. Microsoft Windows Sysmon. Sysmon is a Microsoft product that monitors the registry and the event logs and forwards it. So this is going to be Windows events, operational event log. Here's the operation completed successfully for Sysmon, creating a key. This is a registry key being created for some reason, and so on. Like I say, you could read these one by one, and that's pretty much for the birds, but it gives you a clue of the kind of data, many different kinds of data being stored here. So let's find something to search for. And so the first thing I want to do, I showed you the source types and we talked about them, so you understand basically what's going on here. And now, by the way, what you're mostly learning from now on is not really Splunk, it's event logs. What you must do is get familiar with the most common types of event logs. The most important one is the Windows logs. And I used to teach Windows XP desktop support, and you had to learn how to read Windows events logs. And they're a little bit screwy, and you have to get used to them. And if you haven't already done that, that is going to be a lot of the learning curve here, is what Windows event logs look like. They have the most important thing about the Windows event log is the event ID. They come with a number, and if you Google that number, it'll tell you what it means. Microsoft documentation is completely useless, but if you Google it, other people have made lists of what those event IDs mean. And so there's eventid.net, it's one of the winning websites, but if you just Google an event ID, you'll find real system administrators telling you what that means. Anyway, then we'll play with that. So first let's look at some stream data. This is records of HTTP events on the internet, on the network. And this is what Splunk is doing live network monitoring. That's another feature you can turn on. It was one of those input sources. So it is in fact looking at web events on the network. So I want to keep searching within this index. So I add source type equals stream HTTP to it. And now both of those things have to be true. So I had 1,029 events. Now I'm going to have 26 events, because out of those 1,000 events, only 26 were web requests. Now I can see a bar here showing me how many events second by second, so I could click on this to narrow down the time range if I want to. These are web events. And so you'll see now bytes in, bytes out, a client IP and a number of data packets. Here's, looks like HTML page somebody loaded. Then there's a destination IP. There's various IP addresses here. So you can read this event one by one. Another thing you can do is you can stop format. You can show it as raw text. This is the actual raw data Splunk works with. And you know, if you really did log analysis before Splunk, you would grep files, plain text. This is what like the file looks like. It's just this long line of text. That's what it actually is. Showing it formatted is the usually considered syntax highlighted is this somewhat more friendly view. But even that's a lot to read. Another thing you might do is go here. And here you'll see that down here, even though I have 26 events, if I look for something like client IP, there's only 3 client IPs here. So if I click on that, I have 23 events from that IP address, 2 from that IP address, and 1 from that IP address. And this is mostly what you're going to do to find things. You do a search that's big and has whatever you want. Then you look down here for something that has a reasonable number of different choices. If it's got 1,000, that's useless. If it's got 1, that's useless. Find something that narrows it down, and then say, what I really care about is this one like 40. I have some reason to believe it's 40. So I click on that, and that automatically adds it up here. And now I'm only seeing events with that client IP address. This is really fun. That's how you do it. And like anything else, at first you tend to fall off the track and get lost. And if you're into a command line, you can turn to type it all here, but using the mouse is in practice a lot better because you never make typos or anything. And you get to narrow things down. So let's carry on and find some real events here to get you started. So the web server is called I'mReallyNotBatman.com. That was the fake web server they set up to be attacked. So I want to find HTTP events. Now I'm going to do this the sleazy way. Splunk people, by the way, the official Splunk people say you should use this format for your queries, name equals value, because that is the fastest. But if you're just a sleazy bum and you just want to find the answer, you can just use it like Google, which is what I do. If you just put something there without name equals value, it will just look for that string somewhere in that long line of text, which is in principle slower, but I don't care. It's the simplest way to find the answer. So this is going to find events of HTTP that contain that string. Now, there's no reason it would contain that string anywhere other than the host name, but in principle it could. So now I found 31 events that have that string in it. So they're events that go to the web server in practice. Now, let's go back to here. Okay, 251 events are what I should find. And the reason I didn't find them all here is because I'm still doing sampling. So let's turn off the sampling and see what I get. And now I'm getting thousands of events. So let me see if I missed something. Stream HTTP bots v1. I'm really not Batman.com. And I think that's right. This one here I did with 1/100. That's right. In my instructions here, I was using 1/100 sampling. So let me try and follow my instructions a little more carefully, which is here. Sampling 1 to 100. There we are. And now I find 217 events. And if you look at these instructions, I said I expected you to find, I think, 252. And that's because there's a little variation. It's random. Yeah, so anyway, now I find some events. Okay, now we can scroll down to see the most recent events and see the client IP and so on. Now, we can now spot bad traffic already because this data is full of attacks, of course, that's why it's here. I used the smaller data set that removes most of the normal traffic. So pretty much everything you see in this is actually attack traffic. So let's take a look here. We have, this is a cookie being sent up. This says document moved. That was the response. So this was a 302 redirect or something. And if I just look down here to see what these requests look like, let me make my page a little bigger. This is some kind of search in Joomla. This web page uses Joomla. They're searching for something using a couple of phrases. Nothing too exciting about this one. This looks like a fairly normal web request. So let's go down to the next one. Here's a document moved. Nothing is jumping out at me as painful here. Let's see if I can find a bad one. Usually you'll find a bad one pretty soon. And if not, I'll just go to the next step where we get rid of the filtering. The filtering means sometimes the bad stuff is not visible in the particular query you ran. And I think I'm going to say that's what happened here. All these are not like blindingly obvious attacks. So I'm just going to go and get rid of the filtering. Let me check my instructions. Yeah. So here, all right, the first thing I want to do is find the vulnerability scanner. I want to find events like this. And you'll see this event is obviously an attack because it has this .. / junk in it. And that's not normal. That's an attempt to do a directory traversal attack. This is a really old attack from the 90s. You would go to a website like this and you put in .. / to try to go up and hit configuration files and other things. And the reason why it appears is not that anybody expects directory traversal to work anymore. It hasn't worked since the 90s, but because they're running an automated vulnerability scanner. And vulnerability scanners try every stupid attack in the world. And so they have really noisy and obvious. So all I have to do is quit sampling, and you'll see it in one of the most recent events with this data. So I turn off sampling. Now I should find 20,000 events or something. Let's see. I'm really not Batman. It's still searching. It'll put a check mark there when it's done. 5,003, 22,000, and there. Now it's put a check mark up here. It's done. 22,200 events. So now one of the events close to the top should be that one with all the .. slashes in it. And I shouldn't have to hunt too hard to find it. If it irritates me, I can actually search for .. / but I shouldn't have to. However, it appears to be irritating me. Let me see if I can figure out what I've done wrong. Other than that, I'm just going to deliberately search for .. / Anyway, I want to, even if I don't see that, I might see the, here we are. This is what I was hoping to show you. This is the scanner, Acunetics. This is a known vulnerability scanner. These guys used a commercial vulnerability scanner to scan the website to find attacks. This is what amateur hackers do. They use commercial products. Commercial products do not want to be used by criminals, so they advertise the brand of the product in every request. So that anybody that sees this product will hopefully know that is my team conducting an authorized test, and if not, those are bad guys. So you'll see the name of the product right here. Now, a slightly higher grade of script kiddie would have at least modified the tool to quit saying that. But anyway, so now you know the name of the scanner. So this tells you a lot of things. I know the name of the product scanning me, and now I know which IP address is attacking me. Whoever sent me something that says Acunetics scanner is a bad guy. That's not a legitimate customer. So the source IP of that, which is this client IP, that is the IP address of the attacker right there. So I'm going to save that, put that someplace. That's useful information. So let's see, the IP of attacker is that, and the scanner name is Acunetics. So I'm getting useful information here. And so now let me do a little bit more, and that's as far as I'm going to go. So we find the attacker IP. You can find the web server IP too. That's the destination of that same event. The same event gives you all three of these. And then I can find the defacement file name. And this is the part I wanted to show you. So now here's what happens on a proper network. The servers are only servers. If I have a web server, it should never be a client. Nobody should be opening a browser on the web server and going to a site and downloading a file. There's two reasons for that. In the first place, it's dangerous and unsanitary. That file might have a virus. In the second place, bad guys are going to take over your server. And what they will do is they will run malware on your server, and the server will try to phone home to a command and control center. So you should have firewall rules that prohibit your server from initiating any connections. your server should never send a SYN packet out to anywhere. It should only be responding to SYN packets. If you want to connect to a server, you do that somewhere else, your web server. So I want to find traffic that goes backwards. If there's a connection coming from the web server to some other host, that's evil. So let me find the web server's IP address here. This is the client IP, and this is the destination IP. This is the web server. So my web server is that. So now, if I go back and I look at all the HTTP content, this should be pretty easy to do. Here's my HTTP. Now, if I leave this I'mReallyNotBatman.com here, that's only going to be traffic to my web server, which asks for the web page. If I take this out, I will see all the web traffic on my network. And I better turn on some event sampling so this doesn't become slow and irritate me. All right, this is all the web traffic on my network. Now, if I go to client IP here, I will see, here's the attacker sending hundreds of points in and so on. One thing I don't see is my web server ever as the client IP, because that should never happen. There should be no web request coming from my web server. Now, in fact, it did happen, but I'm not seeing it with this, this filter. So I'm going to try 1 in 10 and see if I get lucky. And that'll be a little slow, but not too slow. It's done already. Now my client IP shows 5 events, and there it is. Those are, nope, there it is. I happen to be lucky. This is one of the many ways to get there. These are requests that came from my web server, and those should never happen. So if I click on that, it will add it up here. And now I see 2 events. Now I can get rid of the sampling. And these, I'm going to find 8 events, if I remember this correctly. 9 events. These are 9 events where the traffic went backwards. And this is when I decided I had to learn and teach Splunk. This is really great. I had 1 million events, and this is how easy it was to find the 9 that went against traffic. And these are malicious events. This is when the bad guy took control of the web server and opened a browser and went to a web page and downloaded something, and that should never happen. In a proper network, you would block this at the firewall. This network didn't do that. But still, I can know these are malicious events because the bad guy did it. And now I can just read these events and find out what they did. And of course, what they did was go to a page, download a file, put it on a web page, and deface the server. And you can find the domain name they went to, and the IP address they went to, and the name of the file they downloaded by just reading these events. So I think that's as far as I want to go today. But that's what you're doing here. You're finding these things. Now, I was planning to have you guys turn these in by emailing in screenshots, and I think that's what I'll do. So I'm going to put, this has an old CTF scoreboard, but I don't think I want to use that for City College classes. So I'll replace this after class with a little thing telling you to mail it in. Just when you find, I have a whole bunch of challenges here, and they end in a flag. So when you get a screenshot showing it, save a screenshot, and then we'll just be emailing in screenshots with the flags highlighted to the same place where the other projects go, which is CNIT.50SAM, I'm pretty sure. So I'll have the exact instructions up here after class. This is, don't use this kind of CTF scoreboard at City College. It's better to have screenshots coming in. Are there any questions? Well, I guess that's it. Let me see if there's any more questions online. Here, there might be something in the chat message if I can figure out what happened. Oh, it's down here, that's why. Looks like there's nothing in the chat. Okay, good. All right, I guess I'm going to stop the share. I'll hang around for a while. I'm teaching another class this afternoon, so I'm around if anybody wants to work. I can open the hacking lab if anybody wants to work on stuff today. I'll do that. Science 37 we can't use because they're doing a competition in there. But you, yeah.
In the password protected class material,
yeah.
The first link is broken.
Okay, I'll take a look at that. All right, let me stop the share and maybe I can fix it right now. All right, I'm stopping the share.